GLP, Good Laboratory Practice, presented by Sandeep Badade. Introduction. In the early 70s, FDA, United States Food and Drug Administration, have realized cases of poor laboratory practice throughout the United States. FDA decided to check over 40 toxicology labs in depth. They revealed a lot dishonest activities and a lot of poor lab practices. Examples of some of these poor lab practices found were equipment not been calibrated to standard form, therefore giving wrong measurements, incorrect or inaccurate accounts of the actual lab study, and incompetent test systems. Although the term, good laboratory practice, might have been used informal already for some time in many laboratories around the world, GLP originated in the United States and it had a powerful effect worldwide. Definition of GLP: the quality as the capability to systematically produce the same product to meet the same specifications time after time. GLP was altered to protect the integrity and quality of laboratory data used to back up a product application. The definition of the term, good laboratory practice, itself, which identifies GLP as a quality system related with the organizational process and the conditions under which non-clinical health and environmental safety studies are planned, performed, monitored, recorded, archived and reported. Purpose of GLP: everyone makes mistakes, that's why GLP is needed. GLP principles are a good idea even if you are not required to follow the standards. There are some simple rules such as, say what you do, with written standard operating procedures, do what you say, follow the procedures, be able to prove it, with good record keeping. The principles of good laboratory practice, GLP, is to support the development of quality and validity of test data used for determining the safety of chemicals and chemicals product. Hence GLP aims to decrease the occurrence of mistakes or mix-ups through large and specific labeling requirements. The registered information can be provided by demonstrating the application of the correct item in the stated amounts to the pertinent test systems. The principles of good laboratory practice GLP is based on 4 principles. 1. The management. 2. The quality assurance. 3. The study director. On 4. The National Compliance Monitoring Authority. All of them serve important functions in the concordancy of performing and monitoring safety studies, and it should be kept in mind that all of them are required for GLP to achieve quality data. Although GLP differs from other quality systems in aspects that are important not only for the traceability of data but especially for the full reconstructability of the study, there are certain company occurrences between GLP and other quality systems like accreditation schemes. Good laboratory practices may be summarized as follows: 1. Test facility management. 2. Quality assurance program. 3. Meeting the requirements of the test facility. 4. Equipment. 5. Receipt, handling, sampling and storage. 6. Standard operating procedures. 7. Performance of the study. 8. Reporting of study results. 9. Storage and retention of records and materials. 1. Test facility management. Test facility means the persons, premises and operational units that are necessary for conducting the non-clinical health and environmental safety study. A test facility is a physical location where one or more phases or components of a single overall study are conducted. This includes the people who work there and are responsible for performing the studies. The test facility should be of appropriate size, construction and location to meet the requirements of the study. It should be designed safe enough to get the validation results confidently. Research laboratories should be supplied with appropriate resources to maintain product's identity, purity, strength, stability. 2. Quality assurance program. Quality control is the process, procedures and authority used to accept or reject all components, drug product containers, closures, in-process materials, packaging material, labeling and drug products, and the authority to review production records to assure that no errors have occurred, that they have been fully investigated. The quality and reliability of test data count on the state and condition of the test system which is used in its production. This is meant to be the control of a number of technical features and specifications which are needed to ensure the integrity of the system and the quality of the data generated. In a study for compliance with GLP, the most important aspects may be characterized as suitability, capacity, and integrity. 3. Meeting the requirements of the test facility. The GLP principles do not address the question of the specific requirements for the location of an archive, except that it should be of suitable size, construction and location to meet requirements. Therefore, there is complete freedom for every test facility to define the location of its archives and to designate the proper locations for each type of materials to be stored. The facilities should be designed for the best suitability to the studies that are to be performed within. Some comfort for the employees comes of course with all the requirement of study quality, which means that the people working in a facility should certainly have sufficient room to move around in order to be able to perform the duties which the study calls for, and to perform them in a manner compatible with the quality, integrity and validity of the study. The test facility should have a sufficient and suitable number of rooms or areas to assure the isolation of test systems and the isolation of individual projects, involving substances or organisms known to be or suspected of being biohazardous. There should be storage rooms or areas as needed for supplies and equipment and should provide adequate protection against infestation, contamination, and/or deterioration. Facilities for handling test and reference items should be planned. To prevent contamination or mix-ups, there should be separate rooms or areas for receipt and storage of the test and reference items, and mixing of the test items with a vehicle. 4. Equipment, including validated computerized systems, used for the generation, storage and recovery of data, and for controlling environmental factors relevant to the study should be suitably located and of appropriate design and adequate capacity. Equipment records should include name of the equipment and manufacturer, model or type for identification, serial number, date equipment was received in the laboratory, copy of manufacturer's operating instructions. Equipment used in a study should be periodically inspected, cleaned, maintained, and calibrated according to standard operating procedures. Records of these activities should be maintained. Calibration should be traceable to national or international standards of measurement. Instrumentation validation is a process necessary for any analytical laboratory. Data produced by faulty instruments may give the appearance of valid data. The frequency for calibration, revalidation and testing depends on the instrument and extent of its use in the laboratory. 5. Receipt, handling, sampling and storage sample tracking vary among laboratories. Receipt, handling, sampling and storage should be prepared appropriately. Records including test item and reference item characterization, date of receipt, expiry date, quantities received and used in studies should be maintained. Handling, sampling, and storage procedures should be identified in order that the homogeneity and stability are assured to the degree possible and contamination or mix-up are precluded. They should maintain the unmistakable connection between a set of analytical data and the samples from which they were obtained. Original source of samples must be recorded and unmistakably connected with the set of analytical data. 6. Standard Operating Procedures, SOP. According to EPA, Environmental Protection Agency, GLP regulations, raw data means any laboratory worksheets, records, memoranda, notes, or exact copies thereof, that are the result of original observations and activities of a study and are necessary for the reconstruction and evaluation of the report of that study. Logbooks for recording temperatures or equipment use, repair, and maintenance, field or laboratory notebooks, forms for field or laboratory observations, training reports, computer printouts, recorded data from automated instrument are examples of raw data. It's so hard and not necessary for anyone remember all these details, and that's one of the functions of the Standard Operating Procedures, SOPs. 7. Performance of the study should be monitorized carefully. All the standards supplied by the GLP should be followed from the beginning of the study to the end by the final report. For each study, a written plan should exist prior to the initiation of the study. 8. Reporting of study results. All studies generate raw data that are the original data gathered during the conduct of a procedure. They are essential for the reconstruction of studies and contribute to the traceability of the events of a study. Raw data are the results of the experiment upon which the conclusions of the study will be based. Some of the raw data may be used directly, and some of them will be treated statistically. The results and their interpretations provided by the scientist in the study report must be a true and accurate reflection of the raw data. 9. Storage and retention of records and materials. Storage and retention of records and materials should be prepared appropriately. The following should be retained in the archives for the period specified by the appropriate authorities: the study plan, raw data, samples of test and reference items, specimens, and the final report of each study. Records of all inspections performed by the Quality Assurance Program, as well as master schedules, records of qualifications, training, experience and job descriptions of personnel, records and reports of the maintenance and calibration of apparatus, validation documentation for computerized systems. Thanks for watching.